Okay. So in this session, I will try to cover first chemical equilibrium, and then I will try to discuss Gibbs-Helmholtz equation, which is a very important equation. So let's start with the chemical equilibrium. What is chemical equilibrium? Means what is equilibrium basically? Equilibrium is a state or position at which the change in concentration, the change in volume will not change during the change of time. Okay. So basically, suppose you have a chemical reaction A plus B to C. And here a chemical reaction A plus B to C, like this. What the mean of this type of reaction we have? So in the left side, you can see we are using a single headed arrow, while in the right side, this is a multiple headed arrow. So whenever the single headed arrow, that is known as irreversible reaction. This is known as irreversible. And this one is known as reversible. This is irreversible reaction and this is reversible. Well, irreversible reaction is a unidirectional reaction. Unidirectional means it will only run from reactant to product. The right side is your product, this is your product, and this is your reactant. Okay. So this is about irreversible. It is unidirectional, means it will not move from product to reactant. It only be reactant to product in one directional. While in case of reversible reaction, it is bidirectional, means it will move reactant to product as well as product to reactant. That's why it is reversible, like this. So this top that is A plus B to C, that is known as forward, while this one is backward. So equilibrium applied for reversible reaction. Equilibrium is valid for reversible reaction, not for irreversible. Any doubt about this one? Please tell me. Any doubt about this topic? Reversible, irreversible? Please respond me quick. No, no doubt. Very good. No doubt. Okay. So another thing is law of mass action now. Law of mass action. Suppose we have a chemical reaction A plus B, which is going to C. So what the mean of law of mass action? According to law of mass action, rate directly proportional to concentration of reactant only. So for this reaction, A and B is reactant and C is my product. So we can say rate directly proportional to the concentration of A and B. Suppose you have any number like 2A plus 3B, that is equal to C. So for this reaction, rate directly proportional to concentration of A power 2 and B power 3. So this value, this digit is known as stoichiometric coefficient. In chemistry, it is known as stoichiometric coefficient, and it will raise to the power of reactant. So rate directly proportional to the concentration of A power 2 and B power 3. Any doubt? This is the law of mass action. Tell me. Any doubt? No doubt. Perfect. Okay. If you want to write down these things, you can take the screenshot. Okay. So this is the law of mass action. Now I'm going to talk about law of mass action for reversible reaction. Reversible. This is for irreversible. In case of reversible, suppose you have A plus B, that is C into D. C plus D, sorry. This. So we can say for this K is equal to, which is known as equilibrium constant. This is equilibrium constant. So K means concentration of product upon concentration of reactant. So K means concentration of product upon concentration of reactant. So this is my product. And this one is my reactant. So if you will write K, please turn off your mic. So K is equal to, this is my product C and D. So we will write C and D. And this is my reactant A and B, which is A and B. If suppose this reaction is irreversible like A plus B to C, then we can write equilibrium means K. The equation of K is equal to concentration of C divided by A and B. Simple. But as you know that equilibrium only for reversible reaction, not for irreversible. So we can't say anything about this. So this for reversible reaction and this is for equilibrium constant. That is concentration of product upon concentration of reactant. Any doubt? No doubt. Very good. Okay. We can take any reaction like suppose this one I'm talking about, this reaction. Suppose we have PCl5 which breaks into PCl3 and Cl2. So if you will write the equilibrium constant for this, it will be concentration of product upon concentration of reactant. Simple. If you have this reaction, N2 plus 3H2 divided by 2 ammonia. Sorry, our product is 2 ammonia. So K equilibrium is equal to concentration of ammonia. This stoichiometry goes to the power upon N2 and H2. This is N2 and this is H2 power 3. It makes sense to you? Perfect. Okay. Now I'm going to discuss the graph of equilibrium. Listen. One thing I want to tell you, at equilibrium, the rate of forward reaction is equal to the rate of backward reaction. Rate of forward is equal to rate of backward. Means at equilibrium, the change of rate is constant. Means the rate of change will remain constant in equilibrium. I can show you through graph. Listen. Suppose we have a chemical reaction. Here we have a reactant A. It will decrease like this. This is a chemical reaction A to B. And this is B. So you can see here, this is the concentration and this is the time. So you can see here at T is equal to 0, means at a very initial point of any reaction, you know that reactant has some moles, few moles of reactant. That's why reactant concentration is higher than the product. But when time will pass, your reactant concentration will decrease. So I have shown in like this. It will decrease through time. And product will appear, means it will form in the reaction. So you can see. But after this time, suppose this is 5 seconds. You can see after this time or during this time, at this point of time, you can see the rate of change. The rate of change is constant. Means as well as the value as well. Means suppose this is concentration of A and concentration of B is same at this point. So for this reaction, you can see K equilibrium is equal to concentration of product upon concentration of reactant, and both value is same, supposed to be K equilibrium will be 1. So you can see this is equilibrium, this is the equilibrium zone, and this is the graph of equilibrium. Any doubt? Tell me. My request to everyone, please tell me any doubt about this one. Okay. Now we can move to the next. What the mean of this? Suppose we have A to B and K equilibrium is equal to concentration of B divided by A. What the mean of this? It means when you will increase the concentration of B, K equilibrium will increase, because K equilibrium is directly proportional to the concentration of product and inversely proportional to the concentration of reactant. This is reactant. So we can say K equilibrium is inversely proportional to the reactant. Means when you will increase the concentration of reactant, K equilibrium will decrease. Okay. Perfect. One more thing I want to tell you. Suppose you have any reaction A to B. We have a K1 here, means equilibrium constant K1. We have another reaction B to A. Then what will be K2? When you will reverse this reaction, then you can write K2 is equal to 1 upon K1. Any doubt? Suppose K1 is your X, then K2 is your 1 upon X. Because this reaction is just reverse for B to A. It makes sense? Please tell me. Okay, perfect. Now K equilibrium is divided in two categories, Kc and Kp. Kc means for concentration and Kp means for partial pressure. It is very easy to write the expression. Suppose we have a chemical equation, PCl5 breaks into PCl3 and Cl2. And I want to write expression of Kc. So this is the concentration of product. So concentration of product divide upon concentration of reactant. Simple. But for Kp, we have to, there is no need to use this square bracket. We will use in place of square the large P. This P will indicate partial pressure. So we will write P, PCl3 dot again P, Cl2 dot divide by P, PCl5. This is Kp. Any doubt about the expression of Kp and Kc? Please tell me. It is very clear, I think. Yeah, no doubt. Perfect. Now we are going to talk about unit of Kp and Kc. Unit of Kc and Kp. Kc unit is mole per liter power delta Ng, and Kp unit is atm power delta Ng. What is delta Ng? Delta Ng means number of gaseous mole of product minus number of gaseous mole of reactant. Okay, suppose we have this reaction N2 plus 3H2 and 2 ammonia. My question is, what is unit of Kc and Kp? So as you can see, the formula is mole per liter power delta Ng. Delta Ng is your number of gaseous mole of product. So you can say product has just 1 mole. Product has just 1 mole. So delta Ng is equal to 1 minus, and reactant have 4 mole. Reactant have 4, 3 here, 1 here. So overall 4. So that will be minus 3. So we can say the delta Ng value is minus 3, and we will put this value in the mole per liter. So unit of Kc is equal to mole per liter power minus 3. And for Kp, it will be atm power minus 3. Very simple one. Any doubt? Please tell me. No doubt. Okay. So this one is a unit of Kp and Kc. What is the unit for this one? We have this reaction. H2 plus I2, that is 2Hi. My question is unit of Kc and Kp. Who will answer, please? If you know the answer, you can send me on chat box or on my messenger. You have only 2 minutes. Someone is saying -2. It's very tricky question. Yeah, it's 2 minus 2 will be 0. And basically it will be unitless quantity. It has no unit. The reason is that if you will find delta Ng formula is product mole minus reactant mole. So 2 minus, there is a 1, there is a 1. So 2, that will be 0. If delta Ng is equal to 0, so mole per liter power 0, it means Kc is unitless as well as Kp. Any doubt about this? Okay, perfect. Perfect. No doubt. Okay. So this is a very basic idea about the equilibrium, the unit of Kc, Kp. Now I'm going to talk about a very important point, that is quotient factor, which is also related to the Kc, means expression will be same like Kc or K equilibrium. Suppose we have a reaction A plus B and it is C and D. What the difference between K equilibrium and Q? K equilibrium is only valid for that time where the equilibrium will achieve. Means it is valid only for equilibrium. But Q is valid for any time, not only at equilibrium. You can use this one for any time. And the best thing about the both expression is same. Expression is same. Means expression will not change. Means K equilibrium is equal to concentration of product upon concentration of reactant, and same Q is equal to concentration of product upon concentration of reactant. Simple. Please note this. I will tell you what the role of Q. I will tell you what the role of Q. Q is quotient factor. Yes, it will be given in the terms of concentration. Yes. Whenever the square bracket is there, that means this is talking about concentration. I will discuss a question, don't worry. I will discuss a question, then I will tell you what the role of Q and K equilibrium. Don't worry. Please write down. And please turn off your mic. Someone has... Okay, now we can move. Listen. Whenever QC is less than KC, or Q is less than KC, it doesn't mean the reaction will move in the backward direction. And whenever QC is less than KC, it will move in forward direction. And when QC is equal to KC, it will be equilibrium. So suppose we have a chemical reaction. We have a chemical reaction 2A, which goes into B plus C. For this reaction, Kc value is given, which is 2 into 10 to the power minus 3. And in question, it is saying that at any time, concentration of A is equal to concentration of B is equal to concentration of C, which is 2 into 10 to the power minus 4. Then what will be direction of reaction? Listen, what we have to do. Kc is given, so we will find Qc for this. For this reaction, expression will be same, means concentration of B, concentration of C divided by concentration of A power 2. Now you can put the value. Concentration of B, C and A is same, which is 2 into 10 power minus 4. So B is 2 into 10 to the power minus 4. C is also 2 into 10 to the power minus 4. And A is 2 into 10 to the power minus 4 power 2. Now you can see it's very easy calculation. This will be cancelled out. Overall QC is 1. QC is 1. KC is 2.10 to the power minus 3. So which has greater value, QC or KC? Tell me. QC or K? Just answer Q and K. Of course, Q. Yes. So if Q is greater than K, then what should be? If Q is greater than K, it will move in the backward direction. Means this reaction will proceed in backward direction. Any doubt about this? Tell me. No doubt. Perfect. Okay. Thank you so much. Okay, now you can write and we can move to the next. Okay, now I am going to discuss Lee-Chatterley principle, a very important one. LCP, Lee-Chatterley principle. So Lee-Chatterley principle means, suppose you have any chemical reaction A to B. It is a very simple thing, Lee-Chatterley principle. Listen, if you will raise something in the reactant side, then you know that that thing is less in the product side. Am I right? So reaction will move in that direction where you can balance the equilibrium, means the reaction will move in the forward direction. This is known as forward. If you have anything in the greater side in the product side, then equilibrium will shift in the backward to maintain. You can see. And it can be any thermodynamic parameter. It can be temperature, it can be volume, it can be pressure, it can be concentration, whatever you can take. Whenever you will raise something in the reactant side, you know that product has less amount, so the equilibrium will shift towards the product side. If you will raise something in the product side, then equilibrium will shift in the backward side, means towards the reactant side. Any doubt? I will discuss one by one. Means the first effect of concentration, like this. Perfect. Listen me. Suppose I am saying this one. We have a chemical reaction R to P. R simply for reactant, and this is product. So tell me, if I will increase the concentration of reactant, what will be the direction of equilibrium? Tell me, direction of equilibrium. Forward or backward? Very easy one. Yes, more forward, no doubt about it. You know, it will balance the reaction when you will anything increase in the reactant, so equilibrium will move forward. Perfect. What will happen if you will increase the concentration of product? I am saying you will increase the concentration of product. What will happen? Yes, backward. Very good. Okay. What will happen if you will decrease the concentration of reactant? Yes, backward, simple. You know why it will be backward? You can see here, when you will increase the concentration of reactant, the equilibrium will shift in forward. So when you will decrease, it means it will backward. Simple, just opposite. And what will happen if you will decrease the concentration of product? Forward, simple. Any doubt about this one, the concentration effect? Tell me, please. If you have a doubt, I will clear it again. And personally, I don't think that there is any doubt about it. Say no doubt only. Perfect. Now, what if only one part of reactant is increased in concentration? And there is no mean to only one part, the same effect. If you will increase, suppose you have A and B. So you may increase A or B, the effect will be the same. Because both are reactant. Okay, now we can discuss the next effect of pressure and volume. Who can correlate pressure and volume? Tell me, what is the relationship between pressure and volume? Who will answer? What is the relationship between pressure and volume? Directly proportional or indirect? Directly or indirectly? Means inverse. Someone is saying direct. Oh, sorry. Pressure cannot be direct proportional to the volume. No. It is inversely proportional to the volume. Means if you will increase your pressure, volume will decrease. Are you getting my point? Very good. So tell me, what is the relationship of volume with mole? Volume with mole. What is the relationship of volume with mole? Okay, no, nobody, Ronak. Okay. What is the relationship between volume and mole? Tell me, directly or indirectly? Yes, direct proportional. Yes, direct. No, direct. If you have lower volume, number of moles will be high, means lower. So it will be directly proportional. So listen me, what will happen? Suppose you have a chemical reaction 2A plus B that will make C. And my question is, what will happen? What will be direction of equilibrium on increasing pressure? On increasing pressure, what will happen? Listen me. As you can see, when you will increase your pressure, volume will decrease. And in the reactant side, you have 3 mole. And in the product side, you have just 1 mole. So what will happen? Who will answer this? What will happen if you will increase the pressure? What will be the direction of equilibrium? Forward, backward, where? Everyone is saying forward. Who will say about backward? I'm not too sure about backward. I will check. What's your view? I'm talking about you. Backward or forward? You have 30 seconds. So listen, whenever you will increase your pressure, equilibrium will shift in that direction where gaseous moles are less. Whenever we will increase that pressure, the reason is that pressure is inversely proportional to volume. So when you will increase your pressure, volume will decrease. Volume will decrease means number of mole will be decreased. Number of mole will decrease. So you can see your product has just 1 mole and reactant has 3 mole. So it will move in the forward direction. Any doubt about the effect of pressure? Tell me. No doubt. Thank you so much. Okay, what about this one? This one is a very favorite reaction. H2 plus I2, that will become 2HI. My question is, what will happen if you will increase your pressure? What will be the direction of equilibrium? Direction of equilibrium. Tell me. What should be the direction of equilibrium? Yes, they have equal moles. So what will happen? Yes, thank you so much. No change in equilibrium because they have same mole in the left and the right side. So please, you can write here, no effect at equilibrium, no any effect. Okay, it will not influence the direction of reaction because they have equal mole. Perfect. Tell me about this one. N2 plus 3H2, that will give you 2 ammonia. What will happen if you will decrease the pressure? What will be the direction of equilibrium? Decrease the pressure. This time, it is not I'm saying increasing the pressure. I'm saying decreasing the pressure. Very good, guys. Going good. As you know that decreasing pressure, volume will increase. Volume will increase means number of mole will be increased, and number of mole you can see here 2, here 4. So increase, it means 2 to 4. So reaction will move in the backward direction. Any doubt? No doubt. Perfect. So this is about the effect of pressure and volume. And you can say sometimes they will give you in terms of volume. So you can correlate this one. Suppose you have this reaction. PCl5 breaks into PCl3 and Cl2. And the question is, what will happen if you will increase your volume? Direction of equilibrium. Direction of equilibrium. What will happen when you will increase your volume? Increase volume means pressure lower. And you know that what the effect of pressure? Pressure lower means volume increase. Volume increase means mole increase. Mole you can compare here 1, here 2. So 1 to 2, it means forward. Forward. You have both choice. You can correlate with pressure, or you can directly, compare with the number of moles with volume. After 2 minutes, this, session will automatically end. So you can join me again for another 45 minutes. So this is the effect of pressure and effect of volume in the direction of equilibrium. My question to you, you have this reaction N2 plus 3H2 that will give you 2 ammonia. Reaction will move in forward. Option A, removal of ammonia. Option B, addition of ammonia. Option C, removal of N2 and H2. Option D, addition of H2 and N2. Tell me which option is the right choice. Maybe it will be more than one. The question is, the reaction is going in forward direction. So which effect will, favor this reaction in the forward direction? I told you the effect of reactant. I told you that whenever you will increase the concentration of reactant, reaction will move in the forward. So addition of reactant or increase the concentration of reactant. So D is the right choice. And I told you that removal of product or decrease in the product. This is your product ammonia. Removal or decrease, both is the same thing. So decrease or removal. So A and D is the right choice. Any doubt? No doubt. Perfect. Thank you so much. So we have a less than a minute. So anytime this class can be, disconnected. So you can join me again.